Hello everyone, and welcome back to this video series where we are looking at uh, mathematics paper 1 for grade 12. This is the Department of Basic Education, or NSC, so National Senior Certificate, or Matric, so grade 12. We're looking at a paper from, I see here it says 2016. I think I've loaded the wrong paper by mistake. Have I? November 2015. Yeah, okay. My apologies. I've loaded the wrong paper. Let me just... Okay, apologies for that. I had the incorrect question loaded. I think it was the question from some previous videos, 2016. If you haven't seen the 2016 question paper, I also went through that one in some previous videos, so you can have a look at that. But in these videos, we'll be looking at the 2015 paper. So when we start off a new paper, we always just talk a bit about the paper itself. So here we can see, okay, grade 12, maths paper 1. It's an old paper, 9 years old. The syllabus hasn't changed much in the last 9 years. I do think it was a bit harder. There were more things in the syllabus back then. So some things have been taken out over the years. So it is, I would say, a little bit easier now. So practicing on these older papers is actually probably really good practice. If you do well on these papers and you understand everything, you'll be fine end of this year. So of course we have maths paper 1 and maths paper 2. Paper 1 is 150 marks and is 3 hours. So we can rewrite 3 hours as 180 minutes. And you can see 150 marks, 180 minutes. If you work at a rate of 1 mark per minute, you should be done with 30 minutes left over at the end. And it's good to have that extra time at the end of the exam to double check your work, go through everything, make sure you enter stuff in your calculator correctly, double check stuff. And also, in case you encounter any difficult questions or maybe you've forgotten how to solve a certain question, you can leave it and carry on and then circle back to that question after the exam. And it's important to do this because if you spend a lot of your time trying to figure out a question, you might not finish the paper. And then there might be questions later in the paper that you do know. So then you spend all your time on a hard question and you miss some easy marks for stuff that you really do know. So you should just go through the paper and answer all the questions you can and then circle back and spend more time on stuff that you find difficult. Okay. So there are some instructions. There's enough past papers available online and the instructions don't really change. So what I would say is just be familiar with the instructions. Like, for example, you are allowed a calculator, just a non-programmable one. So it's not allowed to be like a computer, like the really fancy calculators, just your basic scientific calculator. Most people use Casio or Sharp. Just know like what's expected in terms of rounding off. I don't think anyone ever assumes diagrams are to scale, but just know they aren't. So you can't get in there with your ruler. Like if they ask you to figure out an angle and then try to measure it directly, that won't work. And we do get a formula sheet. Okay. Just be familiar with these instructions so that on the real day of the exam, you don't spend time with this stuff. You rather spend time with this stuff now. Just know what you can and can't do, what the conventions are. Yeah. Okay, then we get into the questions. So like We're going to do questions 1 and 2 in this video. But like what I would say is like when you see something like 26 marks, you should budget about 30 minutes for this question. If you see yourself going over that, then it probably means you're getting stuck. Just like move ahead and then circle back to it at the end. So this would be in line with like what I was talking about, 1 mark per minute roughly. And then maybe this one, you know, like around 10 minutes as well. Before we actually get into the question, let's just have a look. Okay, so 11 questions, sure. And it seems like the last question is a big one, but we'll get to that later. Just also be familiar with what formulas are given. Yeah, that's the formula for an average, standard deviation, some probability stuff. Yeah, equation of a line. There's some trig identities given as well. In paper 1, I don't think you really use these trig identities, to be honest, and the stats stuff not so much, like standard deviation. That might be more paper 2. But I think it's just the same formula sheet given in both cases. So yeah, it's very, very useful just to know what's here. I mean, we have our formula for basic for finding the derivative using first principles. Yeah, we have some compound interest stuff here, some sequence stuff, sum of an infinite sequence, arithmetic sequence, geometric sequence. Yeah, and then some more interest stuff, and then of course our quadratic formula. So yeah, I mean, you know, gradient of a line, equation of a line, all these things. Yeah, just good to be familiar with what's at the back here, so that you know like what you need to know, what you don't need to know going into the exam. So I wouldn't like spend time trying to cram the arithmetic sequence formula because it's given. And the geometric, for example, like those are given. So I wouldn't spend time cramming those. But maybe some tricks and formulas that aren't included in here would be what you'd need to focus on. But okay. So yeah, it's just nice to introduce the paper, get familiar with what exactly is happening, what Maths Paper 1 is all about for grade 12 matric. Let's actually get into solving some of these questions. So question 1, it seems like for all the papers, question 1 is just usually some algebra, some quadratic functions, factorizing, some simultaneous equations. Yeah, like you can see here, this is simultaneous. Yeah, and it's often worth quite a bit. I mean, it's worth 26 marks, and this is like your, what I would call like some basic maths. So this is like low-hanging fruit because it's 26 out of 150. You can calculate this as a percentage, and what I'm telling you is that this is roughly like 1/7%, which 1/7 is like what, close to 15% of your grade, something like that. I'm just randomly pulling numbers, but yeah, I mean it's quite a bit. So if you do well on question 1, which I think is pretty straightforward, maybe some of the questions have a little bit of a trick, like maybe some students might struggle with this type of stuff, but yeah, it really gets you going. If you do well on this question, you do it quickly. I think it sets a good tone for the rest of the paper as you write it. So yeah, definitely I would say try to maximize the amount of marks you can get from question 1. But okay, without further ado, let's get to actually doing some maths. So let's just rewrite question 1.1.1, we have x squared minus 9x plus 20 equals 0. Okay, now just a couple of pointers. So the examiners say that if a candidate answers a question twice, only mark the first attempt, and consistent accuracy applies in all aspects of marking. So what they're basically saying is there's a couple of ways to solve these quadratic functions. People get taught different tricks. This one is you can factorize. You can probably just use the quadratic formula straight, and if you have a fancy Casio calculator, you could probably just get the answers directly without showing any work. But there's 2 marks for the answers and there's 1 mark for work shown. So you need to find the factors. So this is a 3-mark question. Now, if you take shortcuts, you won't get the full 3 marks, first of all. And second of all, if you do an incorrect method or you factor incorrectly or anything like that, and then you somehow get to a correct answer, your work will still be marked wrong. So yeah, you gotta really be sure what you're doing. Don't just write stuff and try to game the system. Yeah, students have a tendency of just trying to write down as much as they can, trying to do different things and hoping that an examiner is going to get there and sort of see something worth awarding marks for. But they really just look at what's there first, and then yeah, after that, if you're just writing everything you know, you're probably not going to get far doing it that way. So just something to keep in mind. So with this one, it's pretty easy to factorize. So we basically need to find a number that multiplies to give us 20, well, 2 numbers, and adds to give -9. So yeah, I hope you can see that this is just -4 and -5, because they multiply to give 20 and add to give -9. So we can rewrite this as x minus 4 and x minus 5. And then of course we can say x minus 4 equals 0, or x minus 5 equals 0. So x equals 4 or x equals 5. So in the exam, you'd get a mark for finding the correct factors, and then you'd get 2 marks for the 2 correct answers. Okay, let's just clear the space and move on to the next question. Okay. So here's another tip. So when they say correct to 2 decimal places, this means you're not going to get an exact answer. And whilst you can factorize just about every quadratic expression or function, if you're willing to be creative enough with the algebra, in these cases where they say correct to 2 decimal places, you're not getting an exact answer. That means use the quadratic formula. Yeah, we're just gonna use our quadratic formula given here. Yeah, that's what it means. So that, don't even try to factorize. I mean, technically it can be factorized, but I'll let you know right now, it's not simple to factorize that. Just use the quadratic formula. So that's what we're gonna do. We'll rewrite the function, and we have to get it in this form in order to apply the quadratic formula. Let's just remind ourselves that the quadratic formula is this. I can write that 2 better. Okay. So in order to use the formula and solve for x, we gotta rewrite our function in this form. Okay. So all that means is we need to take the 4 the other side. Okay. Now we can plug in to the formula. So b is 5, c is -4, and a is 3. So we have -5 plus minus 5 squared minus 4, a is 3, c is -4, all over 2, 3. Okay. So we can work this out inside the bracket. So 5 squared is 25. Yeah. 25. And then -4 times 3 is -12. And then -12 times -4 is -48. Oh, +48. So then 25 plus +48 is 73. Okay, so we have 73 in here. And then at the bottom, 2 times 3, we have 6. So our two answers for x, the first answer will be -5 plus √73 over 6. And then the second answer will be -5 minus √73 over 6. And I can tell you, like, √73 is not like it's not a perfect square. 73 is not a perfect square, so you're not going to get a nice answer. You're going to get an answer with lots of decimals, and that's why they told us 2 decimal places. So the answers are 0.59 and -2.26. Okay. So how are the marks allocated for this? Okay, so where do you actually get marks from for this question? Well, let me use blue. You get 1 mark for changing the form of the function to the correct form. You get 1 mark. Then you get another mark for substituting into the quadratic formula. And then you get a mark for each correct answer. And that's the 4 marks. Now, there are, like I said, you can do this by factorization. It's not really factorization. It's actually a trick called completing the square. Now, I think completing the square has been removed. I could be wrong, but I think it's been removed from the syllabus. Like, most students don't get taught it because completing the square is like how you would solve this without using the quadratic formula. It's very similar to using the quadratic formula, but yeah, it's a bit more fancy maths. Now, it is a choice. Like, I don't think they'll ever ask you to specifically use the technique of completing the square, but it is a thing and it can be done. So there is a second method to solving these types of questions, but it's unnecessary. If you carry on with maths like in university or later, then you will learn about it and it will be necessary, because there are some situations where you can only use the method of completing the square. But in this case, the quadratic formula is fine, it's easier, and I think it's just, let's not complicate things and keep it simple. Okay, let's move on to the third question. So now we have some interesting stuff going on in the exponent. So we have 2x, and then to the power -5 over 3 equals 64. Okay, so let's just note a couple things here. So when you have x to the power a half, this is the same as saying the square root of x. When you have x to the power 1/3, it's the same as saying the cube root of x. Okay? And then when you have x to the power of -1, it's the same as saying 1 over x. X to the power -2 is the same as saying 1 over x squared. So can you see how fraction exponents work and how negative exponents work? Okay. Now what about when we combine them? So let's give an example. Let's say x to the power of 2 over 3. So x to the power 2 over 3 would be, first let's take the cube root of x, but then remember it's 2 as well, so it's 2 on top, so it's x squared. So it's the cube root of x squared. Yeah. What if we throw in a negative? So x -2 over 3. So same thing, we'll keep our cube root, but now it's negative. So remember, when it's -2, it's 1 over x squared. So in the cube root, we'll have 1 over x squared. Yeah. So now that we have a feeling for what's going on with these different indices or exponents, I think we can have a look at tackling this question. Okay, so the first thing that you need to do is you need to get rid of the 2, because before we can like do any square roots or anything fancy like that, you got to realize that this is 2 and then x. Yeah, so this exponent does not, this index does not apply to 2. So if we do any work before we get rid of the 2, so like if we take the cube root on both sides, we're going to have a situation like this. Okay, now this is messy, this is complicated now. So it's better, why did I write 3? It's better to put the 2, so to divide both sides by 2 first, so that we only have x on the left hand side. Just makes it easier. Technically you don't have to, but I would advise that you do that, because the exponents, the indices, the -5 over 3 only applies to x, not to 2. That's the problem. If this was in brackets, then we wouldn't have to worry about the 2, because when we take a cube root, it will apply both to 2 and x. But yeah, so let's divide both sides by 2 first. So that and that cancel, that gives us 1, that gives us 32. So we have x -5 over 3 equals 32. Okay, now I think yeah, I mean, if you're super familiar with indices, then all you have to do here, like there's some tricks, but you can also just use your calculator. I would advise against using your calculator, because you might miss some marks if you just use your calculator. So the trick here is to realize that you can rewrite 32 as 2 to the power 5. And now this is useful because we have 5 happening on the left hand side and 5 happening on the right hand side. So that's useful for us. Okay. Now, I hope you can see this. This is where you might get lost. We can say that x equals 2 to the 5 and then we just flip the exponent. So we reapply it this side as negative 3 over 5. Now, just go through these rules, these examples again, and then think about what I've done here and convince yourself that it makes sense. Okay, convince yourself. And then we're going to do some more mathematical trickery here, and I hope you can see that this and this cancel. Okay, I hope you can see that. Maybe, okay, I'll give an example here. So if you have x to the power 2, and then you raise this to the power 2, this is the same as saying x2 times 2. So when you raise a power to a power, they basically multiply. Okay, so in our case we had 2 to the 5, and then we had 1 over 5. Okay, let's forget about the negative 3. So when we multiply 1 over 5 and 5, we just get 1, 2 to the 1, which is the same as just 2. So the 5s cancel. So I hope you see that. Take a second, think about it, convince yourself. You can do it in your calculator to see that it really does cancel. And then what we're left with is that x equals 2 to the negative 3. This is equal to 1 over 2 to the 3, which is 1 over 8, or 0.125. Okay. Now, how are the marks allocated for this question? So you will definitely get a mark for dividing both sides by 2. Yeah. You'll also get a mark for changing 32 to 2 to the power 5. And then you'll also get a mark for putting the exponent of x and putting it to 2 to the 5. And then you'll get a mark for your final answer. Now, there's lots of ways to approach these types of questions. Definitely a lot of different ways you could have gone about this. And what I would say is, if you chose some other methods, you might still get the full 4 marks, but there's a good chance you probably only get 2 or 3 marks if you don't follow it this way. If you do anything else, like just use your calculator, you might only get the final mark for the answer. So yeah, you gotta know your indices, laws of exponents, and yeah, you gotta know how to solve these questions using algebra this way to get the full marks. Okay, so looks like they've given us a quadratic, but they're being tricky because I mean, they're putting stuff in square roots, and you got x both sides of the equal sign. You can tell it's a quadratic because x appears twice. That's a good rule of thumb. You know it's a quadratic because x appears twice. Yeah. Oh, okay, wait, let me just mention some other things about 1.1.3. So I'm not sure if logarithms are still part of the syllabus. I think they are, laws of logarithms. So you could have used logarithms to solve the question as well, and that's totally fine. I mean, there's a lot of different ways to solve it. I suggest like just sticking to the algebraic method, the one we went through, but you can use logarithms and you'll still get full marks if you use logarithms. Just be careful with logarithms. If you're not comfortable with that method, then just, study the algebraic way. But yeah, okay, so we have a quadratic function here for 1.1.4. Now, they're being tricky, so let's rewrite it, get it in its standard form, and then see if we can solve it. I'm not sure if we can factor or if we're gonna have to use the quadratic formula. As a rule of thumb though, like always try to factor first. Don't just blindly use the quadratic formula, because as I said, you might lose marks. You'll get the marks for the answer, but you won't get the marks for like the work, showing you working. And it's a 4-mark question, 4 marks. So yeah, you don't want to just get like 2 out of 4, because that's what'll happen if you just use the quadratic formula, because I think we can factor this. So this square root sign is kind of making it difficult to do anything. So let's square both sides first. Okay. And then of course this and this just cancel. So we'll just have 2 minus x on the left hand side. On the right hand side, we'll use the FOIL method to multiply. So when you have something like this, you just gotta imagine it's just the same as saying x minus 2, x minus 2. Yeah, and then you use the FOIL method. Okay. So if you're not comfortable doing this in your head, then you can show all those steps. But yeah, I hope you can see. So x squared, so the first term is x squared, and then you'd have minus 4x and then plus 4. So if you're not comfortable like just getting here in one step, then you can show all the working, it's fine. But yeah. Then what can we do? So let's put everything on one side and get it to 0, yeah? So we'll keep our x squared. We'll have minus 3x, and we'd have plus 2, yeah, equals 0. Okay. Now, 9 times out of 10, you can factor a quadratic function when a is equal to 1. So when there's nothing in front of x squared, then it's often factorable. So we need to find a number that multiplies to 2 and adds to negative 3. 2 numbers. And here we can see it's negative 1 and negative 2, positive 2, no, negative 2. So minus 1 plus minus 2 gives minus 3. Minus 1 times minus 2 gives positive 2. So that works. So we'll have x minus 1, x minus 2 equals 0. Okay. And then we can see that our answer here will just be x equals 1 or x equals 2. But now be careful. Be careful. Because our original function had this square root thing going on. Now, we know that you can't have like the square root of 0. Like, what is the square root of 0? If you put this in your calculator, you're going to get an error. Okay, it's mathematically, we don't know what the square root of 0 is. So we can't have 0 under the square root sign. And we're saying x can equal 2. So we had root 2 minus 2. This is root 0, which we can't have. So honestly, x can't equal 2. So then for an extra mark, you have to say only x equals 1. Okay? Yeah. So that's the trick to this question. You mustn't forget that. So how are the marks allocated? So for squaring both sides, you'll get a mark. For finding the factors, you'll get a mark. And then for finding x equals 1 and x equals 2, you'll get a third mark. And then the fourth mark is for then realizing that it can only be x equals 1. Okay. Again, there are quite a number of different approaches to solving this question. I mean, I can think of 3 different ways of doing it. I've only shown one way, which I think is the easiest approach. So if you've been taught a different way, that's perfectly fine. Do what you feel comfortable with. I just choose to show the methods that make the most sense to me, that I think students would be the most comfortable with. Okay. So question 1.1.5. Okay, so we've been given an inequality. No stress. So x squared minus 7x, correct? Or plus 7x is less than 0. Okay. So what can we do here? So the first thing to notice is you've got a quadratic. So I mean, if you were to draw this function, I mean, it's probably something like that, because it's a positive quadratic. Yeah, that's probably what it looks like. So values of x, I mean, we're probably going to get 2, yeah? It is x squared, so it's quadratic. So you know you're going to get 2 values of x. So what can we do? Maybe we can factor. Let's factor out x. See what this gives us. Okay. So I think now, okay, by factoring, it becomes obvious, yeah, that x, yeah, because you're multiplying two numbers and they have to be less than 0. So you can see that if you think about this, so just try and think about it. So if you think about this, you need to think what values of x would satisfy this, so that when we multiply this out, yeah, we're going to get less than 0. Now, definitely x cannot be positive. If x is like, just think about it, if you plug in, like, let's plug in 3. So 3 plus 7. Can you see all of a sudden this equals 30? And 30 is not less than 0. 30 is greater than 0. So x cannot be positive. I hope you can see that. It has to be a negative number. So what about 0 itself? 0 doesn't work. Yeah, because you're gonna get 0 plus 7, this equals 0, and 0 is equal to 0. It is not less than 0. Okay, 0 is 0. So can you see that all our values of x are going to be less than 0? They have to be negative. Yeah, that's the first thing. But can they be any negative number? That's the next question. So what if it's negative 10? That's a pretty big negative number. What happens if we plug in negative 10 here? What do we get? Well, inside we get negative 3. Outside we still have negative 10. All of a sudden, we're now getting positive 30. So can you see that this only works when x is less than 0 but greater than negative 7? Like, it can't pass 7. So I hope you can see that. Like, it should be pretty obvious, but if you're not sure, you can plug in different numbers and check what works. So from that alone, we can say that x has to be greater than negative 7 but less than 0, and that's our answer. Now, it's a 3-mark question, so this is how the marks are allocated. You'll get 1 mark for factorizing. You actually don't have to factorize, but because you should be able to see this already just from this, but there is a mark for factorizing, so do it. And then you'll get 1 mark each for the interval, so 2 marks for the final answer. And those are the 3 marks. Okay. Alrighty then. So we've done the first 5 questions, and I don't think any of those questions were particularly challenging, and that's worth 18 marks. Wow, that's a brilliant start to this paper. If you get these questions right, you already have 18 marks. Brilliant. Okay, so they've given us something, and they say solve for x and y. So this is a tricky question. I don't think, I haven't seen them phrase a question like this. I mean, it is simultaneous equations because you have 2 variables that you're trying to solve for at the same time, but then, you know, they throw in a quadratic, like they're squaring stuff. This is pretty tricky. So okay, question 1.2 is tricky, but it's doable. Let's walk through it. So we have 3x minus y squared plus x minus 5 squared equals 0. Okay. So the square of any number is always positive or 0. Yeah. So basically what you're saying is, like, whatever this result is, it can't be negative. Like, it just can't be negative. Yeah. Because we're squaring, this is either 0 or positive. Same for this. 0 or positive. So that's the first trick that you need to realize. And when you realize that, you also realize, well, so for the sum of 2 squares to be 0, both squares must be 0. This is why I say this is a tricky question, because the only way that you can get 0 here, because there's no negative numbers, that's what they're saying. The only way to get 0 here is if this is 0 and this is 0. Because if they're positive, like if there's some number, let's say 3 and 0, then you're not going to get 0 as your answer. You're going to get 3. Or if it's 3 and 5, then you're going to get 8. The only way to get 0 is if both square is 0. Like both squares are 0. Okay, this is the tricky part. So what you gotta realize is that because of those reasons, you don't have to like say that. You don't have to like explain the rationale in the exam, but the next step would be to say that, well, I can then say 3x minus y squared equals 0, and x minus 5 squared equals 0. Okay. And now you might be tempted to try and expand these brackets. I would say you don't need to do that. If you were given these functions on their own, then you might want to expand, but honestly you don't. You just need to square root both sides. Yeah, just square root both sides, and remember the square root of 0 is 0, so you can just drop the squares and you're left with 3x minus y equals 0 and x minus 5 equals 0. Now what I will say is, like, often you can't do this, there are reasons why it works in this case, because we've been given this initial equation. If we weren't given that initial condition on top, then we couldn't just square root both sides in the next step. Yeah, I think if you do further mathematics, like later in your education, yeah, you'll remember what I'm saying now, and understand why you can't just do what I just did, but in this case we can. Okay, and then okay, we can see here that x equals 5, and if we know x equals 5, we can plug that in here, and then we see that y equals 15. Okay, and then you're done. So how do we get the marks? How are the marks allocated? So okay, so of course you get a mark each for finding x and y, and then you get another mark each for getting to these two equations. Yeah, and the trick to the question, I suppose, is just to realize that you can go from that to this. Like, that's the trick. Some students might try to expand. I would advise against expanding the square brackets. Like, don't try to expand. It's a trap. Don't expand. I think you probably could reach some answer if you expand, but you're gonna spend a lot of time. Hey, like, I mean, look, this is very quick. We did it in like 4 steps. If you expand the brackets, you're gonna spend like a full page trying to figure it out. Like, don't do that. So yeah, they're being tricky. They're trying to trap us. It's okay. It's fine. Let them try and trick us. Okay, let's have a look at question 1.3. For which value of k will the equation x squared plus x equal k have no real roots? Okay. Okay, so I mean, to understand these questions, it depends what type of person you are. I think if you're more of a visual person, then it would be worth like actually trying to draw a graph. So you can just say like you have a function y equals x squared plus x, and you actually like draw the graph, and I think it might look something like this. I don't know, just guessing what it might look like. Remember, it's quadratic, so you know it's a cup shape, and it's positive, so it's a cup. If it was negative, it would be like a mountain, like that way, but it's positive, so it's a cup. Yeah, I mean, you have something like that, and then you say, yeah, you could say something like, so you want to find, yeah, then you'd have a second line, which is like y equals k. K is some line, I mean, and if it's y equals k, then it's like some line this way. Okay, if it was x equals k, then it would be a line this way or this way. You don't know where it is. So anyways, we're dealing with y equals k. So we know it's a line this way. So the question is, for what value of k does this have no real roots? So what does that mean? It means take the y value here at the turning point of the function, and then for all values below this where the function doesn't exist, there's no real roots. As long as you're above this turning point, so like you're somewhere here where you're touching this function, this is the function y equals x squared plus x. Yeah, as long as your y value is somewhere up here where you're touching it, there's real roots. But if it's below the last turning point below, then there's no real roots. So yeah, so it's a tricky way of just asking you, what is the turning point of the equation? X squared plus x. So this point, and then k would be all values less than that point. Okay. So I don't know visually if that is a better explanation. Maybe for some people it's more confusing. Yeah. That is what they're talking about. So a couple of approaches here. You can definitely use there's one way of doing it is to use the form b squared minus 4ac. You say this is less than 0 and then you solve. Now this method this method is, if you really understand what you're doing, I would, yeah, then do this. It's quick, straightforward. Yeah. If you're not really too sure, yeah, if you're not too sure, then yeah, then you can figure out the turning points of the equation. And if you don't remember how to figure out the turning point, or what you do is you will take this and then you would find dy dx, which is just 2x plus 1, and then you say equals 0. So x equals -1/2. And then you subs in -1/2 back in to figure out what the y value would be. And then here you get 1/4 minus 1/2. And then here you get minus 1/4. Oops. Apologies, this happens sometimes when I've been using my device for too long. But here you get negative, oh, my color's gone back to black. Let's take it to red. You get -1/2. So then the turning points would basically be -1/2 and -1/2. That's the turning point of the function. Oh, not 1/2, 1/4. And then, I mean, what you then just gotta realize is that, so for the y value, k will just be less than that. So then you just say, yeah, k is less than this. And then you're done. Yeah. That to me is the easiest method. Like that's the easiest method. Yeah. And part of this method would be like drawing the graph and explaining like what I had explained. Using this, however, it's a bit of a fancier way of going about it. But if you realize that's from the quadratic formula, that's not a coincidence. It's there by design. So let's have a look at doing it that way. Just for the sake of it. So what we can say is, let's rewrite this. So we can say x squared plus x minus k equals 0. Okay. And then what we can say is that the change has to be less than 0. Okay. Now, yeah. This is where some students might be confused. So what we're saying is that the difference between y equals k and y equals x squared plus x has to be 0, right? Less than 0. And then when it's like that and we combine the equations, we can then, which we've already done here, they've already been combined, we can then apply the identity, I don't know what to call this, identity, I don't know. We can apply this and then solve. Okay, now, yeah, let's apply it. So we say this is less than 0. And then let's plug in values. So, okay, so from here, we have a 1 there, we have a 1 there, we have a 1 there. So it's 1 squared minus 4, 1, 1. Okay, but then we don't know what k is, so this is where we'll put negative k. Okay, yeah. So then we get 1 minus, well, plus 4k, I guess. And then you can see quickly what's happening here. Yeah, when we take that the other side, you get k is less than negative 1 over 4, which is exactly what we had gotten doing it the longer method that I had shown you. We had gotten to negative 1 over 4 as well. This way is a lot quicker, and if you understand it, great. But yeah, you use the method that you're comfortable with. There's actually even a third way of doing this question, but we won't cover that. Okay, is that question 1? Yes, it is. That is question 1. Okay, so this video has become a lot longer than I initially thought, so I think we're going to leave it there, and then I'll do question 2 as a separate video. So thank you.